Once again, here's the mole roadmap. The first of the two calculations we're going to look at in this particular video is mass to moles to representative particles. We're going to start with a mass in grams. We're going to use this particular unity fraction, 1.00 moles, over the molar mass of whatever substance it is we begin with down here in the lower left-hand corner. That'll allow us to convert to moles. Once we're at moles, we can then use Avogadro's number over 1 mole to reach representative particles. And remember, this Avogadro's number of particles, those particles may be atoms if it's an element, molecules if it is a covalently bonded substance, or formula units if it's an ionically bonded substance. And it really makes no difference which of those three types of particles it is, the calculation's the same. So let's take a look at a sample problem involving the conversion of a mass in grams to moles and then to representative particles. Okay, mass to particle sample problem. Determine the number of formula units in 937 grams of calcium acetate. Where to begin? Number one, you better have pencil and paper. You better have your periodic table, common oxidation numbers handout, and of course a calculator. So here we go. We're working with calcium acetate. Obviously the first thing we need is a formula, and that's going to necessitate the use of the handout of common oxidation numbers. Calcium is +2, and acetate is a polyatomic ion. You should locate it in the lower left-hand corner of your handout of common oxidation numbers. It looks like this, C2H3O2, and it's got a charge of -1. So in order to fulfill my one rule of formula writing, that the sum of the oxidation numbers must equal 0, I'm going to need two acetates. And so that is our formula for calcium acetate. Next, I need to calculate its formula mass. Calcium's element number 20 on the periodic table, it has a mass of 40 AMUs. It appears in the formula one time, and that takes care of calcium. Next up, carbon. By now I'm sure you know that it's got a mass of 12. It appears how many times in this formula though? Well, there's a 2 inside the parentheses, a 2 outside, so that's 2 times 2, it's a total of 4. So 48 AMUs for carbon. Next up, hydrogen. We need to be careful with hydrogen. Yeah, its mass is 1 AMU, but it's surprising the number of times that a student will tell me that hydrogen appears 5 times in this compound. And that's because they're adding the subscripts instead of multiplying them. 3 times 2, though, is in fact 6, so there are 6 AMUs from hydrogen. Lastly, oxygen, 16 AMUs, and oxygen appears 4 times in this compound as well. So that's a total of 64 AMUs. We add it all up, we find out that's 158 AMUs for a formula unit of calcium acetate. We don't care about single formula units. We're interested in moles. And what that means is 1 mole of calcium acetate equals 158 grams. Keep that in mind. We're going to need that as a unity fraction down here when we begin to solve the problem. We start with our 937 grams of calcium acetate, and want to make sure that I do a good job indicating what I'm working with here. It's not just grams, it is in fact grams of calcium acetate. Well, if you go back and consult the mole roadmap, you'll see that to get anywhere here, the intermediate, the middle step on all of these calculations is convert to moles. How do I go about doing that? Well, that's where this unity fraction that we need can be derived from the equality right here. I really need grams to cancel out. So what I want to do is put 1 mole of calcium acetate over 158 grams. And once I do that, pause long enough to look. Can you see that grams are going to cancel out? Sure you can. Grams cancel out there and there. Once I'm at moles, if you were to go back and consult that mole roadmap one final time, you'd see that if I've got moles, to get to particles, all I got to do is multiply by Avogadro's number. In this case, 6.02 times 10 to the 23rd, and it's formula units, and I'm running out of room, so I will kind of abbreviate there. All that over 1 mole. Do my math. I find out my calculator says the answer is 3.57 times 10 to the 24th, which is a huge number, 10 to the 24th formula units of calcium acetate. And that's it. Simply done, 2 steps. Remember, the middle step is always convert to moles. Here's your mass to particles practice problem. Convert 23.96 grams of ammonia to molecules. The answer is given to you in red, 8.485 times 10 to the 23rd molecules, or if you want to stick with the 3 significant figures rule, 8.48 times 10 to the 23rd molecules. See if you can work that and get that answer. Here's our particles to mass sample problem. Determine the mass in grams of 8.72 times 10 to the 25 formula units of potassium sulfide. Of course, the first thing I really want to do here is go on and determine the formula for potassium sulfide. Potassium, from the handout of common oxidation numbers, is K plus 1. Sulfide, capital S, 2 minus. Remember, the rule for formula writing, the sum of the oxidation numbers must equal 0. Well, if that's the case, then potassium sulfide has a formula of K2S. And let's go on while we're at it and make the determination of its formula mass. Potassium, element number 19 on the periodic table, has a mass of 39 AMUs. It appears in this compound 2 times, so that's a total contribution of 78 AMUs from potassium. Sulfur, element number 16 on the periodic table, it has a mass of 32 AMUs times 1, and that's 32 AMUs. So the total mass of this particular compound is 120,
does not compute.
Correction, 110 AMUs. And remember, that's for a single formula unit. We're not interested in single formula units. We want moles. So just remember, 1 mole of potassium sulfide is 110 grams. That's going to come in handy here momentarily. In this particular problem, we've got 8.72 times 10 to the 25 formula units of potassium sulfide. I'm going to abbreviate formula units. Okay, at this point, I need to go back through moles. Go look at the mole roadmap. What's the connection between particles and moles? Well, there's Avogadro's number of particles. In this particular case, what I'm going to do is I'm going to put 6.02 times 10 to the 23rd formula units in the denominator. All of that, 1 mole. Okay, can you see that formula units cancels out here? Certainly. Well, once I've got moles, can I go from moles to grams? Certainly I can do that as well. Just go back, look at the mole roadmap. What does it say? To go from moles to grams, I multiply by the formula mass. So what I've got here is 110 grams over 1 mole. Simply becomes a matter of pushing buttons on a calculator at this point. And what that does is it gives me 1.59 times 10 to the 4th grams. And this right here starts with 3 significant figures. This ends with 3 significant figures. So my calculation is complete. 1.59 times 10 to the 4th grams of potassium sulfide. Here's our particles to mass practice problem. What is the mass in grams of 1.99 times 10 to the 24 formula units of sodium sulfate? Good luck.